The chapter sets and exercise 2.2. Let us solve some problems and let us know their solutions from this exercise 2.2. Here is question number 1. If A is equal to set 1, 2, 3 and 4, B is equal to set 1, 2, 3, 5 and 6, then find A intersection B and B intersection A, and are they equal? Look at the solution here. We have given two sets A and B. A is the first set. A is equal to set 1, 2, 3, 4. And B is the second set. B is equal to set 1, 2, 3, 5 and 6. Now we have to find A intersection B. A intersection B means first write the set A intersection, write the set B. This is equal to, since it is intersection, this is the symbol for intersection. Since it is intersection, you have to write only the common elements from both the sets. Here you can find 1, here also 1 is there, therefore write 1. 2, here also 2 is there, therefore write 2. And 3 is common in both, you write 3 also. But 4 is present in the first set and 4 is not in second set, therefore you should not write 4. And 5 and 6 also are not in first set. Even though they are in second set, they are not in first set, therefore you cannot write 5 and 6. Then A intersection B means common elements from both the sets, which is equal to set 1, 2 and 3. Now let us find B intersection A. B intersection A means first write set B. Set B means the set 1, 2, 3, 5, 6. Intersection set A means set 1, 2, 3, 4. This is equal to. Again you have to list out the common elements. Since you are finding the common elements, again 1, 2 and 3 are the common elements. Therefore A intersection B is set 1, 2, 3 and B intersection A is also set 1, 2, 3. Then are they equal, he is asking. Is it clear now? From 1 and 2, you can find from 1 and 2 that A intersection B is equal to B intersection A, both are equal. Now question number 2. If A is equal to set 0, 2, 4 and find A intersection 5 and A intersection A and comment on the result. I shall repeat. If A is equal to set 1, 2, 4, then find A intersection 5. 5 means an empty set. And A intersection A. And comment on the result. Here is the solution. First we have given that the set A is set 0, 2 and 4. Now what to find? We have to find A intersection 5 first. A intersection 5 is equal to, A means set 0 to 4. Intersection 5 means an empty set. Now intersection means common elements. Since there are no elements in the second set, there is no question of common elements. Since there are no elements in second set, the intersection is an empty set only, which is equal to 5. And the second bit is A intersection A. A means set 0 to 4. Intersection again the same set A means 0 to 4. Then what are common elements? The same set 0 to 4 is the common set. Therefore the intersection of A intersection A is equal to 0, 2 and 4. From 1 and 2 you can understand that A intersection 5 is equal to 5 and A intersection A is equal to, you got the same set again. A intersection A is equal to A. Now question number 3. A is equal to set 2, 4, 6, 8, 10 and B is equal to set 3, 6, 9, 12 and 15 and find A minus B and B minus A and comment. I shall repeat. A is equal to set 2, 4, 6, 8, 10 and B is equal to set 3, 6, 9, 12 and 15. Then find A minus B and B minus A and comment. Here is the solution. We have given both the sets. Write the first set. A is equal to set 2, 4, 6, 8, 10. And write the second set. B is equal to 2, 6, 9, 12 and 15. We wrote both the sets. Now let us find A minus B. A minus B is equal to, write the first set A. Set 2, 4, 6, 8, 10 minus B means set 3, 6, 9, 12 and 15. While subtraction, you have to write only the elements that belong to first set only. Now you see here 2. 2 is in first set and not in second set. Then write 2 here. Next 4. You could not find 4 in the second set. Therefore write 4. 6. You can find in second set also. Therefore don't write it. 8. Which is not in second set. Therefore write 8 also. and 10 which is not in second set, therefore write 10 also. Then A minus B means you have to write the elements that are present in first set only, which are not in second set. Then the set for A minus B, the solution for the A minus B is set 2, 4, 8 and 10. Now the second bit, let us find B minus A. B minus A means first write the second set B, that is set 3, 6, 9, 12, 15 minus set A, set 2, 4, 6, 8, 10. Now here 3, but you could not find 3 in the second set, therefore write 3. 6 is there, therefore leave it. 9 is not there in second set, therefore write 9. 12 is not in second set, therefore write 12 also. And if you find 15, you could not find 15 in the second set, therefore write 15 also. Then B minus A is equal to set of 3, 9, 12 and 15. If it is not clear to write down, then the better way is simply cancel the common elements from both the sets. You cancel the common elements. If you cancel the common elements from both the sets, you can cancel 6 and 6. If you cancel 6 and 6, then what are the elements that left in first set? 3, 9, 12 and 15. Write them here as an answer. Similarly, in the first case also, cancel the common elements from both the sets. 6 is common, then cancel it. Then what are left in first set? 2, 4, 8, 10. Therefore, A minus B is set 2, 4, 8, 10 and B minus A is set 3, 9, 12 and 15. Like that also you can find A minus B and B minus A very easily. From 1 and 2, can you say that both are equal? When can you say that two sets are equal? If two sets are equal means their elements should be same. In any two sets, if their elements are equal, then you can say that the sets are equal. From 1 and 2, you can write now that A minus B is not equal to B minus A. Now question number 4. If A and B are two sets such that A is subset to B, then find A union B. If A and B are two sets such that A is subset to B, then find A union B. Here, what is the subset we just come across? We learned what is the subset now. Here we have given that A is subset to B. Since A is subset to B, all the elements of A should also be the elements of B. All the elements of A should be in B. Then only you can say that A is subset to B. So, let set A is equal to 1, 2, 3 and B is equal to set 1, 2, 3, 4. Now you can observe that all the elements of A are also in B, then you can say that A is subset to B. The set A is subset to B. Now, if A and B are two sets, the question is A is subset to B, then find A union B. Now let us find A union B now. A union B is equal to, A means set 1, 2, 3, union B means set 1, 2, 3, 4. Since it is union, you have to write all the elements of the first set and as well as the second set. Then you can write 1, 2, 3 and 4. Therefore, A union B is equal to set 1, 2, 3, 4. Set 1, 2, 3, 4 is nothing but set B. Therefore, this is equal to B. Then what can you understand? We understood that if A is subset to B, then A union B is equal to B. Therefore, we can write A union B is equal to B when A is subset to B. Now question number 5. If A is equal to set X such that X is a natural number and B is equal to X such that X is an even natural number and C is equal to X such that X is an odd natural number and D is equal to X such that X is a prime number, then find A intersection B, A intersection C, A intersection D, B intersection C and B intersection D and C intersection D. I shall repeat. If A is equal to set X such that X is a natural number and B is equal to X such that X is an even natural number and C is equal to X such that X is an odd natural number and D is equal to X such that X is a prime number, then find the values of A intersection B, A intersection C, A intersection D, B intersection C, B intersection D and C intersection D. Here is the solution. We have given that A is equal to X such that X is a natural number. Now what are the natural numbers? natural numbers may start from 1. Therefore, this is equal to set 1, 2, 3, 4, 5, 6, 7, 8 and so on. There is no end. And the second, b is equal to set x such that x is an even natural number. Even natural numbers may start from 2. Therefore, b is equal to set 2, 4, 6, 8, 10 and so on. And c is equal to set x such that x is an odd natural number. Odd natural numbers may start from 1, which is equal to set of 1, 3, 5, 7, 9 and so on. And d is equal to set x such that x is a prime number. The prime numbers may start from 2. Therefore, d is equal to 2, 3, 5, 7, 11 and so on. This is set d. Now we got set A, set B and set D in roster form. But we have given ABCD values in set builder form and we converted them into roster form. Now let us find the first bit A intersection B. A intersection B means A set 1, 2, 3, 4, 5, 6, 7, 8 etc. Intersection set B means 2, 4, 6, 8 and so on. Now intersection means you have to write the common elements. You can find 2, 4, 6, 8 in A. Therefore the common elements are 2, 4, 6, 8 and so on. This is A intersection B. And the second bit is A intersection C. Again the same set A, set 1, 2, 3, 4, 5, 6, 7, 8 and so on. Intersection set C. What is set C? Set of 1, 3, 5, 7, 9 and so on. Intersection means again you can find 1, 3, 5, 7 in the first set. Therefore the intersection of A intersection C is set of 1, 3, 5, 7 and so on. Third bit A intersection D. A intersection D is equal to set A, set 1, 2, 3, 4, 5, 6, 7, 8 so on, intersection set D, 2, 3, 5, 7 and so on. This is equal to set of 2, 3, 5, 7 and so on. This is A intersection D. And fourth bit B intersection C, set B, 2, 4, 6, 8 so on, intersection set C means 1, 3, 5, 7, 9 and so on. You see, if we look at both the sets, there is no common element from both the sets. Why? Because these are even numbers and these are odd numbers. There is no even number which is an odd number, and there is no odd number which is even number. Therefore, there is no common elements in both A and C, and its intersection is an empty set phi. And next bit B intersection D, set B, 2, 4, 6, 8 so on, intersection set D. D means 2, 3, 5, 7 and so on. Now if you observe both the sets, then only 2 is common element. Therefore B intersection D is equal to set 2. Next bit C intersection D. C intersection D is equal to set C, set of 1, 3, 5, 7, 9 so on, intersection set D means 2, 3, 5, 7 and so on. If you find C intersection D, we have to pick up the common elements. Now what are the common elements from both the sets? 3 is common, you can find 5 common and you can find 7 common. Therefore C intersection D is equal to set 3, 5, 7 and so on. This is C intersection D. Like this we have completed question number 5. Now question number 6. Here is the question. A is equal to set 3, 6, 9, 12, 15, 18, 21. B is equal to set 4, 8, 12, 16, 20. C is equal to set of 2, 4, 6, 8, 10, 12, 14, 16. And D is equal to set of 5, 10, 15, 20. Then find A minus B, A minus C, A minus D, B minus A, D minus A, B minus D, C minus B and D minus B. Here is the solution. We have given set A. Write the set A. Set of 3, 6, 9, 12, 15, 18, 21. And B is equal to set of 4, 8, 12, 16, 20. And C is equal to set of 2, 4, 6, 8, 10, 12, 14, 16. And D is equal to set of 5, 10, 15 and 20. These are the 4 sets we have given. Now let us find A minus B now. A minus B is equal to, write set A first minus set B later. Now in order to find out A minus B, you have to consider the elements that are present in first set only. which are not in the second set. If you find 3, you can find 3 in first set and there is no 3 in second set, therefore write 3. Next 6 is not in second set, therefore write 6. 9 you could not find in next set, write 9. 12 is present in the next set, therefore don't write it. 15 is not there, therefore write 15. 18, there is no 18 in second set, therefore write 18. 21, you could not find 21 in second set, therefore write 21. Then a minus b is equal to set of 3, 6, 9, 15, 18 and 21. And second bit a minus c. Again write a set minus c set. Set of 2, 4, 6, 8, 10, 12, 14, 16. Then since it is minus, you come to the first element 3. 3 is in first set. Then can you find 3 in second set? 3 is not there in second set, therefore write 3. Next 6, you can find 6 in here, therefore don't write 6. 9, there is no 9 in second set, therefore write 9. 12, you can find 12 in second set, therefore leave it. 15, there is no 15 in second set, therefore write 15. And 18, there is no 18 in second set, therefore write 18. And 21, 21 is not there in second set, therefore write 21 also. Then a minus c is equal to set of 3, 9, 15, 18 and 21. Now third bit is a minus d. A minus d. Write set a first, this is set a, minus set d, means set 5, 10, 15, 20. This is set d. Now subtraction. Subtraction means you have to write the elements that are present in first set only. 3, you could not find 3 in second set, therefore write 3. 6 is not there, therefore write 6. 9, no 9 here, therefore write 9. 12, there is no 12 in second set, therefore write 12. 15, you can find 15, therefore leave it. 18 and 21 you could not find here, therefore write 18 and 21. So a minus d is equal to set of 3, 6, 9, 12, 18 and 21. And fourth bit is b minus a. B minus a means first write b set 4, 8, 12, 16, 20 minus a set of 3, 6, 9, 12, 15, 18, 21. Now 4 not there in second set, therefore write 4. 8 you could not find 8 in the second set, therefore write 8. 12 is there, leave it. 16, there is no 16 here, therefore write 16. And 20, there is no 20 in the second set, therefore write 20 also. Then b minus a is equal to set of 4, 8, 16, 20. Next fifth bit is d minus a. Set d is set of 5, 10, 15, 20 minus a is set of 3, 6, 9, 12, 15, 18, 21. Again you have to go for the subtraction. 5, there is no 5, and 10, there is no 10 there, therefore write 5 and 10. You can find 15 in both, therefore leave it. And 20, you could not find 20 in the second set, therefore write 20 also. Then d minus a is equal to set of 5, 10 and 20. In other way, I told you that you may please cancel the common elements from both the sets. You can cancel 15, 15. If you cancel 15 common elements, then what are the elements left in first set? 5, 10 and 20. You write them here so that you can get d minus a very easy. And the next bit is, sixth bit is b minus d. B minus d means set b is equal to 4, 8, 12, 16, 20 minus set d. D is equal to set 5, 10, 15, 20. Now what are common elements from both the sets? You can find 20 in both the sets. Therefore cancel 20. If you cancel 20, then what are left in first set? 4, 8, 12, 16. Therefore b minus d is equal to set of 4, 8, 12, 16. Like this, you can complete the exercise 2.2. Thank you, Ananda.